there's another interesting twist on a full adjacency when we're not dealing with a broadcast network like Ethernet. So if we're on a point-to-point network, the results that we're going to see when we do a show IP OSPF neighbor are going to be different. And that's what I'd like to chat with you about and share with you in this video. So leveraging this topology once again, we've used this in a previous video. We have these 4 routers are all tied to this common Ethernet segment. But up here off of R4, we have a serial connection up to R5. Now the encapsulation that's being used, oops, let me change my color there. The encapsulation that we're using on this link, the serial link, is PPP, which is the point-to-point protocol. And the link there is, I believe, 64,000 bits per second. Very, very slow. And the point I want to bring up here is that because this is a point-to-point link, the OSPF routers can recognize that, hey, this is a serial interface with encapsulation PPP. They won't bother or even try, because they think it's a point-to-point network, they won't bother going through the whole process of electing a designated router and a backup designated router and then doing all the full adjacencies back and forth, because they realize, hey, it's just me and one other guy. That's it. So when we have a point-to-point connection and we enable OSPF that includes this interface right here, when we do a show IP OSPF neighbor, let me show you what it looks like. And so here in the lab environment, and I encourage you, if you're at a computer, to go ahead and practice by launching the virtual lab link. Let's go ahead and open up PuTTY on our management computer and open a connection over to R4. So here we are on R4. Let's do a couple things real quick. We'll do a show IP interface brief just to verify that we have interfaces that are up and active. And here we have our serial 3/0 interface that is up, and it's been assigned the IP address of 10.45.0.4. And if we do a show interface space and then S for serial 3/0 and press enter, that can also confirm the type of encapsulation that we have on that interface. Great. So I'll hit Q to quit the output there. And now let's do a show IP OSPF interface. And I'll put in brief there just to verify what we think we have from R4's perspective regarding that serial interface. And here's what it says. It says on serial 3/0, process ID 1, that network 10.45.0 is in area 0. It's got a 29-bit mask. The OSPF cost is $647, and the state is P2P. So it's not looking for being a DR or DR other or BDR. It is simply identified as a point-to-point state. And it also shows here that we have a neighbor attached. Fantastic. And so to see that neighbor, we'll do a show IP OSPF space NE and hit tab and press enter. And it's showing off that interface serial 3/0 that we have a buddy with a router ID of 5555. We're in a full state, but look at this. Ooh, there's a dash there. That's because it's a point-to-point circuit. It's a point-to-point link. So there's no DR others, there's no BDR, there's no DR. It's simply a full adjacency that's been established over that point-to-point link. And also what I think would be important to mention is that if we go back to our drawing here, I think it's important to note that as we have adjacencies and we're sending hello messages and so forth, that OSPF actually uses 3 different IP addresses that it might choose. There is the option for unicast for some of the traffic. Unicast is where it's from a source IP address, a specific one, and destined to a single destination IP address. There's also going to be multicast, and we're talking about 224.0.0.5. That is the multicast group address at layer 3 for any OSPF speaking router. So they're all listening and paying attention to any packets destined to that multicast group. And there's one more. If we have an Ethernet segment, a broadcast network, where there's a DR and BDR, the updates that are being sent to those DRs and BDRs, those use a special update address of 224.0.0.6. And a great way to remember that is that, hey, that DR is better than you. We all have to listen to 224.0.0.5, but in addition, the DRs and BDRs are also paying attention to 224.0.0.6. So if we put a packet capture on all the traffic related to OSPF that's going on, we would see some unicast, a whole boatload of multicast to 224.0.0.5, and if we have a DR involved on the segment, we'd also see some updates to 224.0.0.6. So if you and I were to take a close look with like a protocol analyzer at the traffic between R4 and R5 on that serial link, what we would see is we'd see the layer 3 address on the serial link, which is point-to-point, sending all their OSPF traffic to 224.0.0.5, and the other one happily receiving it. And we wouldn't expect to see any 224.0.0.6 because there's no DR, no designated router for that segment because it's point-to-point. So thank you for joining me in this nugget and also getting a little bit of hands-on practice in the virtual lab, and I'll see you, my friend, in the very next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.